Well, can you guys see my screen?
Yes, Professor.
All right, so today we're going to talk a little more about linear systems, and more specifically, we're going to see some applications. So we learned three methods of solving linear systems. We saw graphing, we saw solving by substitution, and also by elimination last time. So three methods of solving linear systems. Today we're going to see how to apply these to solve some word problems using linear systems. So far, every time that we had a system like this was given to us 2x plus 3y. We had a system all the time when we graphed it or solved it using these. But today we're going to see how to start from a word problem and turn that word problem into a system and then use one of these methods to solve that system. So that's why we call this applications of linear systems. So let's start with the first problem here, first application. Call this example one. Let's say, for example, we have this problem here, the sum of two numbers is, let's say, -2. Their difference is, let's say, let me make up some numbers here. Their difference might be 8. So find the two numbers. Okay, as you can see, this is not a typical problem. This here we're looking for two numbers, not just one. So one way to solve this problem is to turn it into two equations, which make a system. So we're going to have two equations here, one over here, the other one here, just like we saw earlier, which will be basically based on this. Once we have the system of two equations from this problem, we can solve them. So let's see how to do that. So first thing with any word problem, you want to, we have a problem solving strategy or procedure. Problem solving strategy. Okay, so first thing is to read and understand the problem. Okay, so it would be very hard to solve a problem that you don't understand. So make sure you read it a few times as needed till you get it. They say understanding a problem is basically halfway through solving it. So if you understood the problem, you're halfway there. So you just need to go to the next step. So understand it, read it first. Do not try to guess numbers, or start solving before you understand what's going on. Then you want to label. You want to label the missing numbers. Number or numbers depending on what's missing. So you want to understand what's missing, how many numbers am I missing, so know exactly what you're looking for. Okay, know before you go, as they say. Okay, number 3 is to basically you translate that problem after you label what's missing, you understand everything. You want to turn that into a system or equation. So you want to translate the word problem into equations Again, it could be one equation, it could be more depending on the problem. And once you do that, the fourth step, once you have the equation, what do you think the next step is? If you turn the problem, you translate it into a system or an equation, what do you do next with that equation?
Solve it.
That's right. So that's the next step. We solve. And finally, we check.
Graph it.
Depending on the problem needs you to graph it, or usually we check. So 4, you want to solve it, and 5, we check it. Okay, so we're going to add that step at the end. Okay, so let's actually write it right here. So check this solution. Make sure your solution works. You got to check it against the original problem and see if that makes sense. Those numbers, do they make sense? If not, you got to check, backtrack your steps and see where you made the mistake. So let's go over these steps here. So the sum of two numbers is -2. The difference, their difference, meaning the same numbers here, their difference is 8. Find the two numbers. So you need to understand every word here, especially the keywords. So sum, we all know, means the operation here is for sum, operation of course is addition. You get the sum of two things or more by adding them. Of two numbers is, so we're looking for two numbers. Okay, let's label them whatever you want to label them, either A and B, X and Y, whatever. So since we've been using X and Y throughout the past 3 classes for the systems, let's use X and Y. So two numbers, let's call them X and Y. So their sum is -2. Their difference, what do we mean by their difference? What does difference mean in terms of operations? What operation is it? Anybody? What do we mean by difference? What is the operation associated with the word difference? It's simply subtraction. Sum is for addition. Difference means to subtract, as we saw before when we did some word problem. And it's 8. Find the two numbers. Again, referring to the same ones here, X and Y. So there, meaning these two. Okay, the two numbers, when you add them, you get -2. You take the same numbers, when you subtract them, you get 8. So we want to find those two numbers. It might not be easy to guess them. Okay, you can try different combinations. It's not going to be that easy. But when we follow the systems, we can, you'll see that we will definitely find a solution if we translate this correctly and solve it. So we did the first step and second step, so we know what we're looking for. Now let's translate the whole thing into equations. So since we have we have a system here, we're going to have two equations. All right, so what do you think so we did 1 and 2, number 3. Let's translate this line by line. The sum of two numbers X and Y is -2. Give me this as an equation. The sum of X and Y is -2. How would you write that as an equation?
X plus Y equals -2.
That's right. That's X plus Y minus 2. So two numbers, again, we don't know them. When we add them, we get -2. That's one of the equations. So the system should have at least two equations. Now, let's translate the second part. Their difference is 8. Their difference is 8. What's the second equation? Again, difference means minus. Their difference refers to these. So let's put this in an equation like this one. What would it be? Not so much different than this one. We're only changing one word, basically. We're changing sum, we change the difference. So
X minus Y equals negative. I mean, X minus
Mhm.
X minus Y equals 8.
That's right. So we have a difference here. We have a sum. And that's it. This is the important part here. Now we just need to, so we translated the problem into, so instead of words here, instead of words and sentences here, we turn that into a system. It's basically the same information hidden in the two. Now we just need to solve it, to solve this system. So again, we learned three methods. We learned graphing, substitution, and elimination. Here, you can choose any method you want, as long as the problem doesn't tell you which one to use. Feel free to use either one. So based on what we studied before, especially the last class, which method do you want to use to solve the system? Do you want to use elimination or substitution or graphing? Which one seems easy to use? Especially like we did last time. So what do you do here? We can easily cancel the y if we add the two equations. So the method here is elimination.
Elimination.
That's right, elimination. So the elimination basically we just add or subtract the two sides. Here we just need to combine them because we already have two opposites. So this will be x plus x, that's 2x. Y and y cancel out. So these two cancel out.
X equals 6.
Negative 2 plus 8 would be
6.
6. Okay, so 2x equals 6. Finally, we divide by 2, divide by 2.
X equals 3.
Exactly. So x equals 3. That's one of the numbers now that we need. Then we're going to need to find the other number.
So we would plug X into each.
That's right. So we're going to plug x into one of these, either this or this. We're looking for the y. Which one seems easy to use to find the y? Is it equation 1 or equation 2? Looking for the y. This seems easy. It doesn't have a negative, so we don't have to divide by a negative later. So we can use this one. So now we can say find y. Plug x3 into equation.
Y would equal -5.
That's right. It would be after we plug. Okay, so that's equation 1. We're going to plug 3 into it. So 3 goes into here. So 3 plus y is -2. Subtract 3, subtract 3. That cancels, so y is -5. Okay, these are the numbers. What's left to do? We solved the system. Now we're gonna check. We'll see if these actually work or not. So number 5. So we said their sum should be -2. If we add x and y, so x plus y, is it negative or is it 3? Well, let me see. -2. Their sum should be -2. So x is here, 3, plus y, which is -5. Is it -2? Let's find out. So 3 minus 5 here is equal to -2. Yes, in fact, -2 and -2. Okay, so that works. The first part of the equation works. Okay, the numbers actually do add up to -2. Let's see if the same numbers, x and y here, if we do the difference, let's see if we get 8. So again, x minus y, we're going to see if that's equal to 8. So x again is the same one here, 3, minus the y, which is negative 5. I'm going to see if this is equal to 8. How do you simplify this? 3 minus minus 5 is?
So it would be 3 plus 5 equals 8. Because you have invisible, well, you would multiply the negative 1 to the
That's right. This is a double negative turned into a positive, and 8, and of course here 8 equals 8. And the problem is solved. Okay, so it works for both. So the numbers here are x, what was it, x3 and y negative 5. Okay, so this wouldn't have been possible to solve without the system. You may try to guess numbers over and over again. You may be able to guess it, but it's going to take you a long time. You may never see the answer, may never know the answer. But with the systems, as you can see here, you have this reliable, systematic method that we use to solve a problem, and it's guaranteed that you will get your solution if you follow these steps and you do everything correctly. And that's basically one application of solving problems, word problems using linear systems. The wording of the problem might be a little different. You may see different types of numbers of money or whatever, or people, but the concept is the same. The concept is pretty much the same. You just need to understand the problem and get the right system. That's the important part. Get the right system, solve it, and you get your solution. Okay, and this strategy pretty much works with every other word problem. Pretty much, you just understand it, see what you're looking for, try to make an equation or equations out of it, solve and check. Okay, any questions, everybody, about this problem? Everybody, any questions before we move on to another example? All right, let's do
No.
Okay, let's do.
No questions.
All right, let's do another example here. Let's come up with something. Let's say we have a bunch of tickets. So there's a total of maybe 17 tickets. Tickets of 2 different prices. Okay, so if the total cost say, so we have 17 tickets, let me make up some prices. So we wanted a total of 17 of them, so let's say and the other ones, maybe, let's see. Let's say 1,150. Okay, so there is a total of 17 tickets together of different prices. Okay, with two different prices means there's two groups of tickets. Some of them are more than the others. We have the total number of tickets, which is 17. If the total cost of the tickets of all these 17 tickets, well, 17 tickets is 1150. The question is, how many of each ticket do we have? How many of each ticket there is? Okay, so it's a little tricky here. So again, we're gonna have to use a system to solve this. So it's not one number that we're looking for, we're looking for two numbers. It's not like how we have 10 tickets, the price is 60, what is the total price? No, that's very simple, you just multiply. Here, we have, we're missing two things here. Basically the number of the two, of each of the 17 tickets. Number of each of the tickets. Okay, again, let's read that one more time. So there is a total of 17 tickets together of two different prices. If the total cost of all the 17 tickets is this, so when these were purchased or sold, the total money that was made was 1150. But there are two types of tickets. Some are more expensive than the other, so we can't just divide this by this. If they were all of the same price, it would be easy. We just take 1150 divided by 17, we'll get the price of each ticket. But the tickets are different. Like I said, some of them cost more than the others. We have two groups. We have price one and price two. That's all. How many of each ticket there is? So we need to find, for example, the first group of tickets. We have X amount of them. They cost this, and the other group, same thing. I'm going to find how many tickets, and maybe we need to add some more information here to make it a little easier. We should, yeah, so we're looking for the number of tickets. We should add.
It wouldn't be x plus y equals 1150.
X plus y equals 1150. So 1150 is not the sum of the, if X and Y are the prices, yes. If X and Y are the prices, you would add them. But here we're looking for the number of tickets, number of them. We have 17. You could say X plus Y is 17. Okay, X plus Y is 17. So the first.
Because the two different prices would be x and y.
But
that's what we're getting in the equation. So the only thing I got confused between is between using the 1150 and the 17 ticket.
Oh, okay. So since we're looking for the how many of each, the number of each tickets. Okay, how many? That's what we're looking for. So we're going to try. So the X and Y should be based on the number of the tickets that we're looking for. So X plus Y is 17. Okay, we just need to figure out how many of X, how many of Y tickets we have. But we need to add a lot of information here because without it, we wouldn't be able to solve. We should add here two different prices, and we can add, that's important, otherwise it wouldn't be possible. Say different prices. You can say, for example, 50 and 100. Okay, again, so we have a bunch of tickets, 17 of them. Some of them cost 50, the other ones cost 100. We don't know. We want to know exactly how many of these we have and how many of the other ones. We have another information here. We know that the total cost of all the tickets is $11.50. So we have all the information we need to find the numbers. So based on the problem here, so that translates to one equation, total of 17 tickets of two types, two different prices. So the prices are 50 and 100. So this is the first one. So when we combine the number of the two tickets, they could be 10 tickets and 7, they could be 11 and 6, it could be 12 and 5. All of them add up to 17, but we don't know exactly how many. But with the help of this, we can figure out which one of these is appropriate. Okay, so one of the equations is pretty simple. The sum of them is 17. Now we need to come up with the other equation. If this was the number of the first ticket of this group, so to find this the cost of these tickets, we're going to multiply x by. So x is, let's say this is the first group of the tickets, and each one costs 50, right? What is the total cost for this type of tickets? If we have x of them, and each one costs $50, so the cost will be 50 times x. Okay, now we're going to see the other one. So the second type of tickets, they cost $100. If we have y, we have y tickets. Y could be any number. How do you find the total again? Cost of these tickets. Y ticket for 100 will be 100 times y. Okay. Once we know the number of ticket multiplied by the price, same here. What is this supposed to be according to the problem? The total. The cost of all tickets according to the problem is
$11.50.
That's right. It's given here. So that's basically the system. Again, it's all based on the problem. You have to read it, understand it well, and see how to put all the information here into a system. This is pretty straightforward. We have a total of 7 tickets of two different types, two different prices, two different types. So X and Y, A and B, whatever. When you add the number of each of the tickets, you get 17. The second one is, so to figure out this total here, you're going to multiply the first group by 50, for the second group by 100. Some of them are more expensive than the others. And that's about it. This is the important part. Now we're just going to solve it. We'll see which method to use to solve this. Is it elimination or substitution? Let's stay away from graphing for now. Just choose between these two, elimination and substitution. You can use either one, but which one do you think is easier to use? Or you can choose either one, actually, it doesn't matter. So which one do you think you want to use, elimination or substitution? Since we used elimination here already, let's do this one using substitution. To substitute a variable, we need to have it by itself. So for substitution, as we saw before, we need to have one of these by itself. We need to isolate one, it doesn't matter which one. Let's, for example, isolate this. So we need to move this to the other side. So would be positive y moves over, becomes negative y, and 17 stays here. So we got 50x. This one doesn't change yet. Okay, and now what do we do when it comes to substitution? So what do we do with the x? People who were here when we did the substitution method, what do we do with the x now? The x, what is its value here? What do we do with that?
Plug it in.
Second? Since we're using the substitution method, we're going to substitute.
We're going to subtract. We divide.
Not subtract yet. We decided to use the substitution method. So we're going to substitute x with this. So x is here. X is equal to this. So let's remove that. So substitute x in equation 2. So you're going to get 50. 50 times x. What is x equal to again? X. We replace it with this, negative y plus 17. Okay, so we did this. The rest should remain the same. So plus 100y. And then just solve this equation. So the reason we substitute is to get rid of one of the variables, either x or y. Now that we have one equation, there's just one variable, one unknown here, y and y. So it's easy to solve. So we're going to start with distributing. So negative 50y plus 50 times 17 plus 100y, 1150. We combine these two. What do you get? Negative 50y plus 100y would be what's negative 50y plus 100y? It's 50. Y, the sign of the highest. This is, if you multiply these, you get 850. Okay, and 1150. And what is the next step? Again, we're trying to find y. What do we do next? Everybody, you should know this by now. We have done this a million times.
You would basically want y by itself, so you would subtract the 850 first from 1150.
That's right. I'm going to subtract 850 before first.
So then you would get 50y equals 300.
300. Okay.
And then you would divide by 50, or eliminate, or
That's right. Divided by 50 about 50. Y
y
is
would be by itself, and that would be 6. Y equals 6.
60. That's right. Y is equal to 60. Same thing we did before with
Wait,
x.
60. Why would it equal 60? Wouldn't it equal 6? Because it's 50.
Oh, I'm sorry, yeah, that's 6. This, cancel this and this. 300 by 5 is 6. That's right. So now we have the number of the first group of the tickets. Okay, so what is the other, how many tickets left? So again, according to the problem, the number of the total number of the tickets is 17. If one group is, we have 6 of one type, what's the other type? How many of the other type do we have? Or how do you find x? I'm going to plug y into one of the equations. Okay, back to the problem again. So we have x plus y is 17. If y is 6, what is x? X plus something is 17. If this is 6, it's got to be. Or if you can see, we can just plug. So the y goes here. X plus 6 is 17. To find x, we subtract. So x is 11. And that's the number of the tickets that we have. So we have 6 tickets. Okay, so we have 6 and 11. The first group, we have 6 of them, they cost $50. Then we have 11 of the other group with the cost 100. But actually the other way around, you have 6, y is 6, so y is 6 here. So we have 11 and 6. For the first group, the tickets cost $50. You can check that. You multiply 11 by 50. And the other group, 6 tickets, they both cost 100. Let's actually do that. Let's check. So to check, we set the sum of them, x plus y. So 11 plus 6, they must add up to 17. According to the problem, should be 17. And yes, in fact, that checks. Second part is to make sure that we want to multiply each ticket by the price, we get 11.50. So we're going to times 11 by 50, and times 6 by 100. The total must be 11.50, otherwise something is wrong. So the first tickets are 11 tickets for $50 each, plus 6 tickets for $100 each. This has to be equal to 11.50. Okay, so let's do a little math here. So 11 times 50, that's 55, it's 550. 6 times 100, 600. Is it equal to 1150? Are these equal to 1150?
Yes.
Yes, so we have 1150 here. And 1150. And that works. So check the first part, second part of the problem, and that works. Okay, and that's how you use mathematics to solve word problems or real world problems. They're not always written in equations. It's up to us to translate the problem, make it an equation and then solve it, because the problems around us or the issues around us, they're not written like this. It's humans that translate and study the problems and turn them into mathematical equations to solve them. Okay, so this is better than guessing. If you had to guess, you probably wouldn't be able to figure it out unless the numbers were simple or easy or was an easy word problem. But in this case, if you follow this method here, you can get the answer in a few minutes. But if you try to guess, it may take you a while and you may never get the answer. And that's our second problem. Again, every word problem is different. There's no one formula for all, but we do have the blueprint here that works for all the problems. So it's up to you to read the problem as many times as you have to understand it. Once you get this system, that's the most important part. We learn how to solve systems over the past 3 classes. So the rest is just basically understanding and comprehension of the problem before solving it. Okay, so with that being said, any questions here about the solving, everybody? Solving, the steps we studied before, so there shouldn't be a problem with the solving. Again, the important part is the translation here. Does anybody have a question about the solving steps here? Any questions before I give you a couple of these to try on your own? Okay, let me give you a couple of word problems. And basically try to use the same thing. Try to use the same strategies to solve some practice. All right, let's say we have 2 numbers here. And let's say the difference of the 2 numbers is -9. there's some, let's say, it's 5. So their sum is 5. Find the two numbers. Okay, that's one. Number 2 will be let's use the same, pretty much the same concept of the tickets. So let's say say how many tickets? Let's say. So we have 13 tickets. Total of 13 tickets. Total cost. Total cost, let's say okay, so we say the total cost is 460. Two types of tickets, so two types. We have tickets that cost $40 and the other cost is $30. So how many tickets of each? How many of each ticket? Okay, again, we have a total of 13 tickets. Some of them cost 40, others cost 30. We don't know how many exactly of each one, but we know that the total cost of the tickets is 460. It's just the same problem here. I just put a shorter version of it without a lot of stuff. Okay, same concept. I'll give you some time to figure this out. Okay, so take a few minutes and I'll check back with you once you finish. Okay, everybody, you guys done? Hello, are you guys finished with these problems?
For the first one, my equation was x plus y equals 5.
Okay. And then? That's one of the equation. What's the other one?
X plus y, x minus y equals -9.
That's right. X minus y is -9. What did you find for the numbers? So the numbers are, if you solve this, it would be -2 and is it -2? Yeah, so you should get -2 and -7, or actually 2 and so this, the difference is this sum. The sum is 5. Yeah. Okay, and so again, what do you get for the second one? So these are the numbers. If you add them or subtract, you get that. What about the next one? What's the, let's start with the equations first. What is the first equation? So we have two types of tickets, X and Y. 13 of them, so X plus Y is 13. Then the total is 460. We get that total by multiplying x by 40. X tickets cost 40 plus y tickets cost 30. And the total, according to the problem, is 460. Then we use any method of solving, either probably elimination or substitution, and you should get your solutions. Any ideas of what the solution is? If you solve this, I'll give you the answer. So x plus 13. This one is 40x plus 30y. Total is 460. And then you basically either use elimination or substitution, like I said. The solutions should be we have find out x, the number of these tickets that cost 40 is 7. And the numbers of the other tickets, y, that cost 30 are 6. You can easily check this again. If you multiply, you should check 7 plus 6. As you can see, 7 plus 6 is 13. Again, following the exact same steps as here. We're just changing basically numbers, but the problems are pretty much the same.